Assalamu alaikum. In this lecture, we will prove that the regular languages are closed under union, concatenation, star, reversal, complement, and intersection. By this statement, I mean that if we take union of two regular languages, that is L1 and L2, then the new language which would be the union of L1 and L2 would also be the regular language. A useful transformation to be shared with you is that if we have multiple accepting states in NFA, then we can convert it into a single accepting state by introducing a new accepting state and removing the acceptance of the previously accepting state, and then initiating the lambda or the epsilon transitions from the previously mentioned accepting states towards the newly introduced accepting state. This will not change the language of the NFA. And if we have no accepting state in the NFA, then we can introduce a new accepting state with no lambda transition from the previously mentioned states of the NFA, as there was no accepting state. Now to prove the properties, we have two languages, L1 for which the NFA constructed is denoted as M1, and the language L2 for which the NFA constructed is denoted as M2. L1 is accepting the language A power n b, and L2 language is L2 or M2 NFA is accepting the language BA. To prove that the language L, which is the union of L1 and L2, would also be the regular language, we can say that there would exist an NFA that would accept the language which would be the union of L1 and L2. To construct the union of L1 and L2, just have to introduce the new initial state and then map towards the initial states of the M1 and M2 with the lambda transitions or the epsilon transitions. This newly constructed machine is now the union of M1 and M2 and would accept the union of language L1 and L2, and this language is also the regular language. Next, to prove that the concatenation of two languages is also would result into the regular language, we have the M1 accepting A, language A, and we have M2 accepting language BA. Then to prove the concatenation of both of these machines, M1 and M2 accepting language L1 and L2 respectively, we can construct an NFA of the concatenation of these two languages. For this purpose, the new NFA construction of new NFA would start from the initial state of M1, then remove the acceptance of the previously accepting state of the M1, and then initiate a lambda or the epsilon transitions towards the initial state of the M2, and the remaining M2 would be drawn with its accepting state in the newly constructed NFA, which would be the concatenation of M1 and M2, accepting language L1 concatenated with L2. To prove that the star operation is also closed under regular languages, or the regular languages are also closed under the star operation, suppose we have NFA accepting language L1, which is A, B steric. To draw the corresponding NFA accepting the star of the given language, first introduce a new initial state which would be mapping towards the previous initial state with the lambda transition. Then the next remaining NFA of L1 would be drawn as it is. No, we have to remove the acceptance of the previously accepting state. And introduce the new accepting state with lambda transition. Have a mapping from initial state towards the accepting state with lambda transition, and again mapping back towards the initial state from final state with the lambda transition. So to draw the star operation of any language, we have to follow 4 steps. First, introduce a new initial state, then introduce the new accepting state, then map an epsilon transition or a lambda transition from newly introduced initial state towards the newly introduced accepting state, and then map by the lambda transition or epsilon transition from newly introduced accepting states towards the newly introduced initial state. Now this would accept all the combinations of the language L1, which is described as L1 steric, clean closure, and also include epsilon or lambda in the language, as there is a transition from initial towards final of the lambda. As here the language L1 was a power n b, so the steric operation would be the steric on a power n b. That would also be include lambda or epsilon or empty null transition. Now to prove the reversal of language would also be a regular language, we just have to reverse the arrows and make initial state the final state and make the final state the initial state. Here, to draw the reversal of the language L1, which is a power nb and is expressed as NFA M1, the newly constructed machine would be drawn as the initial state of M1 would be the final in the reversal, and the final or accepting state of M1 would be the initial state in the newly constructed reversal of M1, and the intermediate arrows would be reversed with the same input letters on them. To take complement of a language, simply have to convert the accepting states to the non-accepting states and the non-accepting states to the accepting states. That would give of the NFA. Here M1 is the NFA accepting a power n b. Draw the complement of the machine M1 and the language L1. Simply have to convert the non-accepting states into accepting and the accepting state into non-accepting state. This would give us the complement of the NFA or the language. That would also be a regular language as it is being expressed in form of NFA. To prove intersection is also regular, prove it with the help of De Morgan's law. And according to De Morgan's law, intersection L1 intersection L2 is equals to union L2 complement and then the whole complement. First, we have to complement the language M1, which would be accepting L1 as here I say that M1 is the machine accepting L1 and the language of L1 is simply A. There is a machine M2 accepting language L2 which is comprised of the input letter B only. To prove the intersection using De Morgan's law, first have to take the complement of L1, and to take complement we have to convert the non-accepting states to accepting and the accepting states to non-accepting. Then to take complement of L2, similarly have to convert non-accepting states to accepting and the accepting states to non-accepting. Then take union, which is the introduction of new initial state with lambda transitions or the epsilon transitions towards the initial states of the two machines for whom we are taking the union. Now the next step would take the complement of this machine. That would just be to convert the non-accepting states to accepting and the accepting states to non-accepting. This would be the intersection of the two languages L1 and L2, and this would also be a regular language as proved using De Morgan's law. That is all about the properties of the regular languages. Thank you very much.